Have you ever wondered why we expect one AI model to do everything? We ask the same model to write code, solve mathematics, analyze financial reports, debug networking issues, generate images, summarize documents, and even write research papers. But in the real world, that's not how intelligence works. A hospital doesn't have one doctor who performs every surgery. Instead, it has cardiologists, neurologists, orthopedic surgeons, radiologists, and dozens of specialists working together. A company doesn't have one employee doing finance, cybersecurity, software development, marketing, and customer support. Every department specializes in what it does best. Nature itself follows the same principle. An ant colony is intelligent because thousands of ants cooperate. A bee colony survives because every bee has a role. Even the human brain consists of billions of neurons working together rather than one giant neuron trying to solve every problem. So, here is an interesting question: why are today's AI systems still built around the idea that one massive model should do everything? Well, that idea is beginning to change. And leading that change is a Japanese startup called Sakana AI. This is with a fascinating new technology called Fugu. Unlike ChatGPT, Gemini, Claude, or Llama, Sakana Fugu isn't trying to become the biggest language model in the world. Instead, it's trying to become something even smarter, an intelligent conductor that knows exactly which AI should perform each task. Today, we are going to explore how Sakana Fugu works, why researchers believe it could represent the next major step in artificial intelligence, how it compares with existing large language models, and what this means for enterprises, cloud computing, networking professionals, and the future of AI itself. Let's get started. What is Sakana AI? Before understanding Fugu, we first need to understand the company behind it. Sakana AI is a Japanese artificial intelligence company founded by former Google researchers with a simple but revolutionary belief. Instead of continuously building larger and larger language models, why not let multiple specialized AI systems collaborate? The name Sakana means fish in Japanese. The inspiration comes from nature. Schools of fish display remarkable collective intelligence. A single fish has limited knowledge of its surroundings, but hundreds of fish moving together can quickly adapt to predators, changing currents, and obstacles. No central controller exists. Instead, intelligence emerges through cooperation. This philosophy is called collective intelligence. Rather than relying on one enormous brain, intelligence emerges from many smaller intelligent components working together. This same principle inspired Sakana AI's research into evolutionary computing, distributed intelligence, and now Fugu. Why is it called Fugu? If you have ever visited Japan, you have probably heard of Fugu. Fugu is the Japanese puffer fish. It's famous worldwide because preparing it requires extraordinary skill. One mistake can be dangerous because certain parts of the fish contain tetrodotoxin. Only highly trained chefs are allowed to prepare authentic fugu. Why would Sakana AI choose this name? Because their AI also represents precision. Instead of blindly sending every request to one AI model, Fugu carefully analyzes the task, decides which expert models should participate, verifies their work, and combines everything into one coherent response. Think of it as a master chef selecting exactly the right ingredients before preparing a meal. To understand this even better, let's go through the biggest problem with today's AI. Let's think about how most AI assistants work today. You type a question, the request reaches one large language model, That model generates an answer simple. But what if your request is much more complicated? Imagine asking AI to design a secure enterprise network, generate Terraform scripts, review firewall rules, write Python automation, create documentation, estimate cloud costs, and summarize the final architecture. That's actually several completely different jobs: networking, programming, security, documentation, financial analysis. Yet, today's systems often expect one model to excel at all of them. That's like asking a network engineer to suddenly become a lawyer, accountant, doctor, architect, and pilot all at once. Humans don't work this way. Organizations don't work this way. Nature doesn't work this way. So, why should AI? Sakana Fugu's entry into multi agent intelligence will be a game changer. This is where Fugu becomes fascinating. Instead of acting as one giant AI model, Fugu behaves more like an intelligent project manager. Imagine you are managing a large IT project. You don't personally configure every switch, firewall, router, server, and cloud environment. Instead, you assign work. The network engineer configures routing, the cybersecurity expert reviews security, the cloud architect designs infrastructure, the DevOps engineer automates deployment. Finally, you combine everyone's work into one finished solution. Fugu applies this exact philosophy to artificial intelligence. Behind one simple API call, it decides whether to answer directly or assemble a team of AI models, assign specialized roles, verify intermediate results, and synthesize a final response. From the developer's perspective, it's still one endpoint. Behind the scenes, it's an intelligent orchestra. Let's move on to the orchestra analogy. Imagine attending a symphony orchestra. There isn't one musician trying to play every instrument. Instead, you have violins, cellos, trumpets, flutes, percussion. Each musician specializes. Standing in front is the conductor. The conductor rarely plays an instrument. Instead, the conductor coordinates everyone. He knows exactly when each section should begin, when to pause, how loudly to play, and how every individual contribution becomes one beautiful performance. Fugu is that conductor. The AI models are the musicians. The final answer is the orchestra's music. And that's why many researchers believe orchestration may become just as important as building bigger models. Most AI assistants today follow a very straightforward pipeline. You type a prompt, the prompt is sent to a large language model, the model processes it using billions of parameters, and then it returns an answer. Whether your question is simple or incredibly complex, the same model is responsible for everything. Fugu takes a completely different approach. Instead of assuming that one model has all the answers, Fugu first asks a very important question: what is the best way to solve this problem? That might sound simple, but it's a profound shift in how AI systems are designed. Let's also understand AI orchestration. The key technology behind Fugu is something called AI orchestration. Think about how an airport works. When you arrive at an airport, there isn't one person checking your ticket, loading your luggage, fueling the aircraft, flying the plane, and handling air traffic control. Instead, dozens of specialized teams work together. Check-in staff handles passengers, security officers inspect baggage, ground crews prepare the aircraft, pilots fly the plane, air traffic controllers coordinate hundreds of flights simultaneously. Every specialist performs a specific task, and the passenger experiences the entire journey as one smooth process. Fugu applies the same principles to artificial intelligence. Rather than relying on one gigantic model, it intelligently coordinates multiple AI systems, each contributing where it performs best. To the user, it still feels like talking to a single AI assistant Behind the scenes, however, several AI models may be collaborating to produce the final response. Let's understand the steps involved in the request. In the step number 1, the very first thing Fugu does is analyze your prompt. This isn't just about understanding the words you have typed, instead, it tries to understand the intent behind the request. For example, imagine you ask design a secure enterprise network for a company with 2000 employees, provide firewall policies, generate Terraform code for deployment, estimate Azure costs, and prepare documentation. Immediately, Fugu realizes that this isn't a single task, instead, it identifies several independent problems: network architecture, cybersecurity, infrastructure as a code, cloud pricing, technical documentation. Instead of asking one AI model to handle everything, Fugu decomposes the problem into manageable pieces. This process is often called task decomposition. Humans naturally do this every day. When planning a vacation, you don't solve everything at once. You first decide where to go, then you book flights, then hotels, then transportation, then activities. Breaking large problems into smaller ones makes them easier to solve. Fugu applies the same strategy. The step number 2 is choosing the right experts. Once the task has been broken into smaller components, Fugu decides which AI model is best suited for each one. Imagine you own an IT consulting company. If a client needs firewall optimization, you probably won't assign that work to a web designer. If they need Kubernetes automation, you won't ask your accounting department. You assign work based on expertise. Fugu does exactly the same thing. One model may specialize in coding, another might excel at reasoning, a third could be particularly strong in mathematical calculations, a fourth may generate high quality summaries. Instead of forcing one model to perform every task equally well, Fugu leverages each model's strength. This significantly improves both efficiency and accuracy. In the step number 3 is all about parallel processing. Here is another clever feature. Many tasks don't depend on each other, that means they can run simultaneously. Imagine building a new office. Electricians don't need to wait for painters to begin every part of their work. Interior designers can select furniture while networking teams install switches. Security engineers can configure CCTV systems while construction crews finish the walls. By working in parallel, the entire project finishes much faster. Fugu applies the same concept. Instead of processing every subtask one after another, it can execute multiple AI tasks simultaneously whenever possible. This reduces overall response time while improving productivity. For enterprise environments, this parallel execution could become extremely valuable. The step number 4 is verification. One of the biggest weaknesses of today's AI systems is hallucination. Sometimes an AI sounds extremely confident while being completely wrong. We have all seen examples where AI generates fake references, imaginary research papers, or incorrect commands. Fugu attempts to reduce this problem. Rather than blindly trusting one model, it can compare outputs from multiple models. If two models agree on an answer, confidence increases. If they disagree significantly, additional reasoning or verification steps can be triggered. This resembles how engineers review each other's work. In many organizations, critical firewall changes require peer review. Cloud deployments require approval. Code changes require pull requests. The same philosophy applies here. Verification before delivery. Let's move on to recursive intelligence. Now let's talk about one of the most fascinating concepts behind Fugu. It is none other than recursive orchestration. Suppose Fugu receives a task that is far more complicated than expected. Instead of trying to solve everything immediately, it can divide that problem into even smaller tasks. Those smaller tasks may themselves require additional orchestration. In simple words, Fugu can orchestrate another orchestration process. Think of a multinational company. The CEO doesn't personally manage every employee. Regional managers supervise country managers supervise department heads supervise individual teams. The management structure forms multiple layers. Similarly, Fugu can create multiple layers of AI coordination. This hierarchical reasoning enables increasingly complex problem solving. Why this matters for networking professionals? As network engineers, many of us spend hours troubleshooting issues. A VPN isn't connecting, OSPF neighbors remain stuck, a firewall policy blocks traffic, a BGP route isn't propagating. Usually, solving these problems require several different skills: packet analysis, routing knowledge, firewall expertise, log analysis, cloud networking, documentation. Imagine asking one AI assistant to troubleshoot all of this. Instead of one model making educated guess, Fugu could potentially assign routing analysis to one specialist model, firewall inspection to another, log interpretation to another, and documentation generation to yet another. The final result would feel like consulting an entire engineering team rather than a single chatbot. That's a very exciting direction for enterprise AI. Let's also understand dynamic resource optimization. Another advantage of Fugu is intelligent resource allocation. Not every question deserves maximum computing power. If you ask what is an IP address, there is no need to involve 5 different AI systems. A lightweight model can answer instantly. However, if you are designing a global SD-WAN architecture connecting hundreds of branch offices with redundancy, compliance requirements, security policies, and cloud integration, the workload becomes much more demanding. Fugu can dynamically decide how much computational effort should be invested. Simple tasks remain inexpensive, complex tasks receive additional reasoning resources. This improves both cost efficiency and performance. Sakana Fugu represents a shift in AI design philosophy. Instead of asking, how can we build one bigger model, it asks, how can multiple intelligent systems work together more effectively? It's a surprisingly human way of thinking. After all, modern civilization wasn't built by one genius doing everything, it was built by billions of people, each contributing their own expertise. Perhaps the future of artificial intelligence won't belong to the biggest model, perhaps it will belong to the model that knows how to collaborate. And that is exactly the vision Sakana Fugu is trying to bring to life. In the next part of our discussion, we will compare Fugu with ChatGPT, Gemini, Claude, Grok, DeepSeek, and Llama. We will also explore its benchmarks, enterprise use cases, limitations, and whether this orchestration approach could redefine the future of AI. If you are enjoying this deep dive, don't forget to like this video, subscribe to the Network Fixer, and hit the notification bell so you never miss out our in-depth explanations on networking, AI, cybersecurity, and emerging technologies. Thank you for watching, and I will see you in the next part. Until then, take care of yourself and have a great day. Bye bye.